Hello, this is Derek, and this is section 7.2, factoring trinomials. And in this section, we're going to look at two flavors of trinomials. And this first version is going to be the kind where it's just a plain x squared or whatever squared up front, but basically the coefficient is a 1 for the leading coefficient. And in the second half, we'll look at the versions where they're not that. So for this first kind, we are basically doing a reverse FOIL. So let me just pop a FOIL problem up here for a second. So if we have that, and I FOIL, remember we go first, and that's x squared, and then we do outer, 5x, we do inner, 3x, and then last. So that is 15. And then we collect our like terms in the middle. And so this one would come out to x squared plus 8x plus 15. And so when we're working with multiplication, we had the two binomials, we FOIL them together, and we get a trinomial. So in this section, we're starting with the trinomial, and we're trying to get this factored back to those two binomials. Okay, so then the steps for getting backwards is, step 0 for every factoring problem is if there's a GCF, factor that out. And then this really only has one step, which is find the numbers that multiply to be C, the number on the end, and add to be B, the number in the middle. And the reason for that, and that's this x squared plus bx plus c. So b is our coefficient on our linear term, in this case 8, c is the number on the end. So here we're just saying what multiplies to be 15 and adds to be 8, because remember our original numbers multiply to be that 15 and they go 3 plus 5, they add to be 8. So that's how we're going to factor all of these, is what multiplies to the end and then also adds to the middle. There will be an infinite number of numbers that add to the middle, so focus on what multiplies to be the end. So for this first example, I got I need to multiply to be 35 and add to be 12. If we think of 35, there's only two pairs that make 35, 1 and 35, which is an easy one to forget. Sometimes that's the right one though. And then 5 and 7. And 5 and 7, those add to be 12, so that is the right pair. So we set up our parentheses, and then notice in this case they're multiplying to be positive 35. So that means my numbers have to be the same sign. They either both have to be positive or they both have to be negative. Since this 12 is positive, both signs are positive. And you'll see there's 4 possible combinations here as we go through these examples. So this is positive on the end, positive in the middle. And again, multiplies to 35, and if we did our FOIL x squared right there, plus 7 plus 5, there's our 12 and 35. For this next one, we're looking for two numbers that multiply to be 30 and add to be negative 17. So since, again, this is a positive number, what that tells me is both the numbers have to have the same sign. They're either both positives or both negatives. Since this time my cross term, or that middle term, is a negative, I know both numbers have to be negatives. So now I start thinking through things that make 30. And if you're like trying numbers and you can't figure it out, you're like, 5 and 6, that's not 17. 3 and 10, that's not 17. You're not seeing it. You can always go 1 and 30. Okay, so those add to 31. That's not it. Does 2 go in? Yep. 2 and 15. Okay, there it is. 2 plus 15 is 17. So you can always just start the list, and you are eventually going to find that number. So right there, that would have been all my possible combinations, and I just got to look for the 17, which is here. So this one will be x, but now minus 2 and x minus 15. Again, both negatives to multiply to positive, add to be a negative. So here, this example, we get a negative on the end. So that means we're going to have mixed signs. We're going to have one positive sign, and we're going to have one negative sign. And in this case, because this middle term is positive, the positive is going to be the larger of the numbers, because when I add them together, it's going to dominate. So notice for these two examples, when we add them together, 5 and 7, that's 12, 2 and 15, that's 17. But in this example, if I think of what multiplies to be 28, it's going to be 1 and 28, 2 goes into 28 14 times, and 4 goes into 28 7 times. So if I'm just looking at these pairs of numbers, none of those add to be 12, but that's because I'm not paying attention to the signs. And so what I want to do when it's a negative is think of this as being the space in between the numbers, rather than the sum. For me, at least, that's easier. So then I look at the 2 and the 14 and I go, ooh, those are 12 apart. I need one of these to be negative. That's going to be that -2, right? Because the -2 and 14 keeps this as a +12. We'd already decided the big number got the sign. So here we got x, and then 2 and 14. And again, the 14 is going to get the positive because the middle's positive. 2 gets the negative. And again, the mixed signs because of that being a negative. This next example, all that happened here was I wrote it backwards. So let me write it in descending order. So that would be x squared and then minus x minus 30. So that's going to be another negative. So we're going to have mixed signs. So a positive and a negative. And in this case, this is the too easy, it's hard. There's an invisible 1 there on that x. So this means that they are going to be 1 apart. So if we think of numbers that multiply to be 30, 6 and 5 multiply to be 30, and they're going to be 1 apart. So this time, this is a negative value, so we want the 6 to be, we want the big number to take the sign to the middle. So the 6 is going to be negative, so when we go -6 and +5, we end up at -1. Okay, so then, cap invasion. Okay, we just had a little cap interlude there. So for these next couple of examples, we have, it's the same exact thing, except there happens to be an extra letter going on. So for here, when I set up my parentheses, in this first slot, I'm going to have q times q to get q squared. And on the end, the only difference is I'm going to have r times r to get the r squared on the end. And when I do the cross terms, there'll be QR and then RQ, which is the same thing as QR. So now I just have to find 2 numbers that multiply to be +54 and then add to be -15. So in this case, they're both going to be negatives. And I think -6 and -9 should get that done. So -6, -9. The other thing I don't think I've said yet is it doesn't matter what order you put these in. In the same way that 2 times 3 equals 6 and 3 times 2 equals 6, it doesn't matter which order we write those. Over here, this one is not currently leading with a 1, but that's because this has a greatest common factor. So we will pull the greatest common factor out first, because that's kind of our step 0 for every problem. This is just the first one that's had one. So, and then let's see, we had x cubed, x squared, and x, so I'm pulling out x, 3, 12, and 63, so I'm pulling out a 3. And that's going to leave x squared, 3 goes into 12, plus 4x times 3 goes into 63 minus 21. And that's going to be 3x and x plus, so we need something that multiplies to be -21 and adds to be 4. So that means they're going to be 4 apart. And with 21, right, there's not that many things. It's 1 and 21, or it's going to be 3 and 7. 3 and 7 are 4 apart. So 7 is the big number, so it's what's going to dominate. That gets the plus, and then minus on the 3. Okay, so next up is the kind where the leading coefficient is not 1. And these are a fair bit more difficult. This is definitely the hardest of the versions of factoring. I'm going to show a couple of ways to do it. I have things I like about both versions and things I don't like as much about both versions. And so pick the one that makes the best sense to you and then use that. So for both of this one's going to be magic method, the next one will be AC method. Some books will also call that factor by grouping again, because the last step of the next one is grouping. So for here, we're going to go factor out the GCF at present, and it isn't. We multiply A times C, so that's this first times the last. So 5 times 8 would be 40. And then we do the same thing we just did, which is what 2 numbers multiply to be, but now 40 and add to be 22. So basically we're having to account for that 5 in front. So what multiplies to be what used to kind of be the end and adds to the middle. And that, in this case, multiplies to 40, adds to be 22, is going to be 20 and 2. So then what we do is we write out the factors with the extra factor of A. Okay, so check it out. This is the magical part. We go 5x, and then we go 5x again. And one of those is fake, but that's okay. We're going to deal with it in a second. We put in the numbers we just found back in the last step. And then if I multiply this back, I have 5x times 5x, that makes 25x squared, not 5x squared. So that's where we have this extra factor of 5 running around. And all I do is I just divide it out wherever it would have been the common factor. So I'm kind of putting it in there for convenience and then taking it right back out. So I end up with x plus 4 and 5x plus 2. So I'm just writing it there and then dividing it back. The reason for that is if I try to do this as a guess and check, this is the method I wouldn't recommend using, because as soon as the numbers get a little bit harder, guess and check is really difficult. But if I try doing this as a guess and check, what you do is you set up the first parenthesis with an x, and you know it's going to have to be an x and a 5x. And this one has pretty easy numbers. Sometimes they don't have this easy numbers. So for 8, it would have been 1 and 8 or 2 and 4. And then you just start trying the numbers. You put in 1 and 8 and go 8 plus 5, that would make 13. Nope, that one's wrong. What if I put the 8 here and the 1 here? And then you'd have 41. Nope, that didn't make 22. And you keep trying these combinations until you got them in the right order. So that's the terrible way to do it. So that's kind of what I like about this, is it eliminates all that guessing and checking. You just get your two numbers, you put them in, and you reduce it, and everything comes out right where it should. I'll do one more version of magic method, and then I'll do a couple more examples, and I'll use AC method next time. So for this one, 30 times 15 would be a terribly large number, so this is a good place to remember that we should always look to see if there's a GCF. And in this case there is. I could take a 5 out front. And so 5 goes into 30, that would be 6x squared. 5 goes into that one, minus 7x. 5 into 15 would be 3. So this time we got to figure out what we're multiplying to. Remember, we go 6 times negative 3 from negative 18. And then we ask what multiplies to negative 18 and adds to be negative 7. Or because it's a negative, again, I think of it as what's 7 apart. So that would be a 9 and 2. And the 9 is going to be negative because the big number takes the sign of whatever's in the middle. So then here, I'm just going to write out the 6x. So I'm throwing in that extra factor 6. I put in my numbers. And, oops, it should be plus 2. And then here at this step, we're dividing out whatever would be the greatest common factor. So 6 and 9, the biggest thing is 3. But remember, I have an extra 6 in here, so I'm not done. I gotta look at this next factor in this case. 6 and 2 also has a common factor, and that's 2. So once I reduce out those common factors, that should match the extra I put in. In this case, I put in an extra 5, so I divided out 5. But because this one was a 6, it could split up across the two factors. So here we would have 3 into 6 makes 2x, 3 and 9 would make 3, and there 2 into 6 makes 3x plus 1. And that would be fully factored. And then with any factoring problem, we can always FOIL and check, by the way. So here if I did this, I would go 2 times 3 get 6x, plus 2x on the outside, minus 9x on the inside. There's our 7x, negative 3 times 1, there's our negative 3. Okay, and then last step is AC method. So same thing, factor out greatest common factor if there is one. And it starts the same. We do 5 times negative 3 and get negative 15, and then look for two numbers that multiply to negative 15 and add to be negative 2, which will be a negative 5 and a positive 3 in that case. And then we find, so we did this, that was step 2, sorry. And then step 3 is rewrite the polynomial to be factored out so that the middle term bx is written as the sum of the two terms whose coefficients are the numbers found in step 2. Ooh, that's a lot of words. Okay, so what all that just said was to rewrite this minus 2x as minus 5x plus 3x. So 5x squared minus 5x plus 3x. So notice I didn't change it, it's still minus 2x, I'm just giving it a different look, and minus 3. And then what I can do here, now it's a 4-term problem, and I can do that grouping that we saw back in the last section. So we cover up these two, and we go, what can I take out of there? A 5x, x minus 1. What can I take out of these two? A plus 3, x minus 1. So there's that greatest common factor that comes out front and leaves behind 5x plus 3. So there's AC method. So they both get you the exact same spot. It's just a matter of which one you prefer to use. This next example is the one where I don't like AC method when there's a greatest common factor, just because people don't do a very good job of keeping track of the parentheses and they get confused. Okay, so our greatest common factor in this case is a 3. So we'll go 3 and then 5x squared plus 8x minus 13. And then from there, we're going to go 5 times negative 13, and that will be negative 65. And they need two numbers that multiply to be negative 65 that are 8 apart. And so that's the 13 and the 5 again, except the 13 will be the positive and the 5 will be the negative. So now I have to rewrite this using 13 and 5. So here we're going to go 3. I'm going to change this over to a bracket because I have some more parentheses coming up and I want to distinguish between them. So this is going to go 5x squared, and then I can put either the 13 or the negative 5 in here. It will work either way. That said, that negative 5 looks like it'd be easier to factor with, so I'm going to put that one. And I'm going to put the 13s together just because it would be easier. And then I'm going to take a 5x out of these two. And then here's where it starts getting a little bit messy. So 5x comes out, and then x minus 1. From these two, we're going to take a 13 out. So 13 x minus 1. There's that greatest common factor. And so what I kind of encourage people to do is just to pretend that none of that's there and just write it down like you would. So that'd be x minus 1 and then 5x plus 13. And then just to realize it has that common 3 in front. But right here, people get all screwed up getting from this line to that line. So this is pretty much, that's the thing I don't like about AC method. Whereas when we do this with the common factor doing magic, it just sits out front and you just kind of cancel everything. And for me, that's less confusing in terms of the handwriting, but whichever you prefer is good.